Hey, my name is Ben. Thanks for stopping by. I'm going to give you a quick walkthrough on this HVAC system that we're working on for the ductwork. So we're going to talk about the supply and the return, and right here is where the furnace is ultimately going to be located. We don't have the hole cut for the plenum yet coming down here, but there will be a hole cut right there with our probably 16 by 20 plenum coming down to the top of our furnace. And then we're going to have our return air ductwork coming right down here and going into the side of the furnace. And that's going to be a 10 by 25 return air drop. The system that we're working on is going to be a 60,000 BTU furnace paired with a 3-ton air conditioner. So the first thing I'll talk about, I guess, is just briefly the ductwork sizing. I will link to a friction rate calculator or a duct calculator in the description of this video for you guys to check out. But some really just rule of thumb sort of things that I can tell you right now is that for a 3-ton air conditioner, 8 by 24 is about right. For a 2-ton air conditioner, you should be able to get by with 8 by 20. When working with ductwork, you will notice that 8 by something is going to be your most common sizing for your main trunks. So just stick with 8 by something. It's going to make everything a lot easier as far as finding the right parts and accessories, and things are a lot easier to get if you use 8 by something instead of trying to use a larger let's just say like 12 or 14 by something. So we've got our 8 by 24 return air coming across the ceiling here. In this particular case, we did use a little bit of thermopan, and I'm hoping to put up a video on that topic if I haven't already gotten it up. But basically that's just transferring over a little bit of return air to this location right here. Now the return air comes over this direction and makes its way across the ceiling, where it goes all the way up to the top of this open area right here. You can see we have this cathedral style ceiling, or whatever you call this, and warm air will naturally want to kind of pool towards the top of this area. So by having return air way up there, that's going to do a really good job of just making sure that we have good air turnover inside of this space. Now with a really open layout like this particular project, you really don't need to have like a lot of small returns throughout the entire area. You can get by with a couple of main returns strategically placed that are going to serve the entire space really, really well. The one issue that you can run into with central returns is that specific rooms can become pressurized when the door is closed. For example, this room that I'm in right now is a bedroom, and a lot of the time the door to the main area will be closed. So depending on the area that you're installing your ductwork, some areas require you to run dedicated return air ductwork to every space that can be basically closed off. But you can also use this other method, which is basically installing a jumper duct or using a pass-through cut through a wall to basically allow the return air to make its way back into the main area. For example, if this right up here above this door, if you wanted to, you could cut a return air grill on one side and a return air grill on the other side, and that will naturally allow air to pass through. The other thing that you can use is slightly undercutting the doors. If you leave a little bit of a gap under the door, it will allow some return air to kind of naturally make its way back into the main space and ultimately up to the primary return. The downside with both of those is that it allows some sound transfer through the wall. So using this wall right here as an example, a better way that you can reduce that is to cut a return air grill on one side of the wall up higher, and then cut another one on the other side of the wall down lower, and that way the sound has to make a couple of turns before it makes it back into the main space. The other option is an actual jumper duct, and that's basically where you have a duct going up into the ceiling on this side, which is in our main area, and then back over here on the other side we would have it come back down into this space right here, and that would allow return air to naturally push back to the main area. That pretty much covers the return air and kind of understanding what you're working with that. You can have your return air be like completely central, where like the furnace is right there, if for some reason there was open air access to this area with no closed doors, you could have all the return air pulled right on the side of the furnace. But most building officials don't really like that. Even though if it's done properly, it can work just as well or better than a system that has return air going all over the place. For example, at my personal residence, I have all of my return air pull down the basement steps, which are open all the time. There's no door. And it comes just naturally through that stairway and then over to the furnace, and then it's pulled through the rest of the house. If you do have a basement and it's going to be conditioned or partially finished or something, pulling the return air from the basement is actually a really good idea because that air in the basement tends to be a lot cooler, and so it's naturally going to pull that cool air out of the basement and circulate it into the rest of the house. Hopefully in the next several weeks here, we'll have a furnace and air conditioner installation video for you to check out. So if you don't want to miss that, make sure you hit that subscribe button. Now we'll move on to talking about the supply. Again, the plenum is going to come up into this 8x24 duct. The 8x24 duct makes its way across the ceiling down that direction. And quick note, we use Thermopan over there to jump that across the other side, which is basically using the joist cavity as ductwork. You cannot do that with supply air. It has to all be ducted 100%. So our supply comes across the ceiling here, and we have our 6-inch runs coming off into the various areas. You can see we've got one 6-inch run coming over here, serving this small space. And then we've got another one going up over there through the floor with a floor register. And we basically just repeated that process throughout the entire house. You can see down here we have a whole bunch of runs, and some of these are actually just being dead-ended into these cavities for a future addition, so they're not actually connected to anything right now. Here in this big open area, we've actually opted to run a couple of large vents off of that side instead of trying to pull flex duct up through these attic spaces. That will work just as well as having ran long runs through the attic, and probably even better for a couple of reasons. Number one is that a long flex duct run through the attic has a lot of resistance or just friction from the air trying to go through that corrugated piece of flex duct. So you're going to have reduced airflow by the time the air actually makes it to the vent. The second reason is that running ductwork through the attic is the worst possible place you could put ductwork for two reasons. The first is that obviously it's not a conditioned space, so you're going to have significant heat loss or cooling loss because it's running through the harshest temperature differential that you could really choose inside of your building. So that's the first reason. The second reason is that if you do have any air leakage, which hopefully you wouldn't anyway, but if you do, that air is going to leak out into that hot or cold attic, and it's going to be permanently lost. If you can keep all of your ductwork in the thermal envelope, meaning in the conditioned space, it is absolutely the best way to go, because any air leakage from the ductwork is going to just leak into the house. So you really didn't lose any energy or efficiency by having air leakage into the conditioned space. So right here you can see we have a 6x12 wall register that we are preparing. This is connected to an 8-inch boot or takeoff coming off the top of our 8x20 ductwork. So we have these larger vents serving this large area, and most experts agree that it's no longer as essential that you have to have your runs be all the way out next to the exterior wall. It used to be that most guys would say, hey, you need to make sure you get a run all the way out to this far corner right here because it's going to be really cold over here otherwise. Well, with modern building technology and efficiency standards, that's become way less of an issue. You can see with this particular build, this is a double studded wall cavity where there's no thermal transfer through the studs because there's insulation here, 2x4 stud, insulation here, and then interior 2x4 stud. And once the electrical and everything is finished, there'll be another bat of fiberglass insulation going in between here. So no thermal bridging in this particular design. So even though those vents are a good 25 or 30 feet away from me where I'm standing right here, this area is going to mix perfectly fine. The air temperature should be almost perfectly even. A good example would be a project we did recently where we had an HVAC system that was serving an area that's 60 feet by 60 feet. And all of the vents came off one side, looked very similar to what that looks like actually, where they were kind of up about 10 feet or something off of the floor. And that main 60 by 60 area stays very evenly conditioned, despite the fact that there are windows on the opposite side and all of that. Just houses and building is not nearly as drafty as it used to be. So as long as you're getting the right number of CFM or the right amount of heat or cooling delivered to a particular space, the air should mix pretty well. We'll talk about CFM just really briefly, and that's the cubic feet per minute of the HVAC system that you are installing. And usually you're going to be designing for air conditioning. Heating usually requires less CFM. So for a 3-ton system, it's 400 CFM per ton is what the general rule of thumb is. And so we have 1200 CFM to work with on this particular system. So that 1200 CFM that we have should be evenly divided based on the square footage of each area served and the exterior wall exposure. So that sounds like sort of difficult to calculate, but what I like to tell people is you shouldn't worry too much about the exact number of CFM delivered to a particular room. What you should do instead is say, hey, I've got this many rooms, this many square feet in each of the rooms. Let's divide that out and figure out ratio-wise how many vents should be in that room based on its square footage. And for a 6-inch run, we can kind of assume that you can probably get about 100 CFM through one 6-inch run. So for a 3-ton system, you would need to have at least 12 6-inch heat runs for that system to work properly at a static pressure of about 0.1. So 100 CFM per run, you'll have 12 runs. Divide that amongst the number of rooms you have based on square footage and just install those and you will be good to go. Now if you want to go above and beyond, like we did on this project, you can add more runs than necessary and be able to basically have a lot more flexibility in balancing the system. So what we did here is we actually ran a total of 21 runs. I think it was about 21 runs. So even though we only needed 12, we almost doubled the number of runs that we are installing. And that's going to do two things for us. The first thing is that it's going to allow us to balance the system. So that means I could close some of the vents partially. I could close some of the vents all of the way. So like if, let's say, for some reason you weren't going to use half of your house or the downstairs or the upstairs and you want to just close it off for the season or mostly close it off, you could do that safely with this particular installation. We could close 8 or 9 vents 100% and the system would still work properly. So that's the first benefit, is that you can do that. Because as an HVAC tech, we've ran into the issue very frequently where we'll go out to someone's house and the furnace is riding limit, meaning that the furnace is basically over capacity and it's heating up too much and having to shut off the burners, and then the fan keeps running and then the burners come back on again. That's called riding limit. Or in air conditioning season, the A coil, or the coil on the furnace, the evaporator coil on the air handler, will be froze up and ice will have accumulated on it. And the most common reason for that and the riding limit issue is the guy that lives there or whatever went down into the basement, closed all the vents because he's like, well, we're not using this space right now, and their system most likely was designed with the minimum number of vents. So if you close half of the vents in your system, you're going to not have enough CFM to be able to allow that equipment to continue to function. So all that to say, basically, don't be afraid to add extra runs. If you're like, hey, I want to add an extra run in this area right here for convenience because I might want to close the other one off, then just add it. It's fine. Worst case scenario, you shut the vent and it's no big deal. So the second reason that having more vents is better is that now instead of pushing 100 CFM through per run, in this particular installation we're going to be pushing more like 57 CFM per run. And with 57 CFM per run, that's going to be like a nice gentle flow of air coming through each vent, which makes the installation a lot more comfortable. You're going to have a situation where you really don't even notice like blowing air sounds from when your furnace comes on, because every run has a very just slight amount of air coming through it, or a little bit less than what a like minimally designed system would be. So it just makes it a little bit more comfortable, in my opinion, when you have like a gentle breeze coming out of a vent instead of like a blast of air where you can like see the curtains waving or papers blowing on the floor because of the air conditioning turning on. So let's briefly talk about a couple of installation details. We'll just talk about these floor registers really quick. A 6-inch boot, we call this an angle boot. That's what we have installed here. It adapts from that 6-inch round pipe under the floor to a 4x10 rectangle that is going to allow us to drop one of those floor registers in. You can see we made a template here, and we brought this around the house to different spots. That holds it 4 inches off of the wall, and then we just used some spray paint to mark it out. You can see we messed up several and had to move them over, but that works really nice. And then when you nail these boots in place, use some just like roofing nails with the flat heads so that you don't have like a screw head sticking out into the boot, otherwise you won't be able to drop your floor register through. I'm going to make a list of ductworking tools, and I will put those in the description for you guys to click on, and you can see all of the best tools that I recommend. I've done a lot with ductwork over the years, so I've had an opportunity to spend a lot of quality time with my tin snips and things like that. Since the ductwork is below the floor here, we're using all floor registers throughout this space upstairs here. Downstairs though, we are going to be using round ceiling diffusers. So the ductwork is going to be coming down out of the ceiling. You can see we simply have a 6-inch 90 screwed to the side of that 2x10 there, and that's going to allow us to install a round ceiling diffuser. The product that I actually like to use is called an Easy Air Grill, and I didn't have the right rough-in flanges with me. I'll try to link to them in the description of this video if I can find them. But normally that 90 would be dropping onto a little collar, a plastic collar that screws to that floor joist, and then our final round adjustable ceiling diffuser would slide into that. There are several different options for your ceiling diffusers, so it doesn't have to be specifically the one that I recommend, but that's just what we typically do. You can see in a couple of areas we're going to have to soffit out the ceiling and drop it a little bit. So in this particular room back here, there's going to be a sizable soffit, but it's only 8 inches deep, so it's actually not that big of a deal, especially in a situation like this where we have 9-foot ceilings. And then we're running it across above these 2 closets, which makes it makes good use of space that otherwise wouldn't have been used and is less intrusive in the living area. All of our rectangular duct was assembled using a combination of S-cleats and drive cleats. So the end right there is a drive cleat, and then the horizontal piece right there, that's actually a standing S-cleat because it has the additional rib facing down. And then we just have some small little brackets that we installed and were able to hold the ductwork in place. I'll show you just a few of the different fittings that we've been using. This is it's called a full tab 6-inch takeoff is what we would generally refer to it as. This portion right here is actually 7 inches across, and I marked out all those holes and cut them out by hand with just a regular tin snip, and that's what comes off the top of the ductwork all the way across. For each one of those runs we have a 6-inch takeoff, with the exception of those 2 8-inch ones that are just a little bit bigger. These are a few of the different boots that we were using. This is the angle boot that I was talking to you about. 4x10, again, is the best size for the rectangular portion, 6-inch coming into it. So those are angle boots. This is also a 4x10 boot, but this we call a torpedo boot, or I don't know what the proper name for it is, to be honest, but we generally refer to them as a torpedo boot because of how it's shaped. And it's, again, 6-inch coming in, 4x10 going out. Here we have some just regular 6-inch 90s. You'll use lots of these because 90s are not only 90s, 90s are also 45s, or, let's see, 22.5s if I can get it to turn. But you can basically turn these into whatever shape or position that you need them to be, so they're very, very versatile. Right here is just an end cap that we use on the end of our large trunks running across the ceiling. And I guess that's the one other thing I should mention a little bit more is the necking down of your supply. So as you run your supply ductwork, you are able to then reduce it in size. Now, my general preference is actually to not reduce as much as you technically could. So right here we've dumped off a couple of runs, and then there's a couple more down here. So let's say in theory we were down to 800 CFM at this point from 1200. If that were the case, we could reduce to 8x20 right here. But you'll see that this actually continues in 8x24 all the way down until we're like halfway or a little bit more through our ducting system. Then I did neck it down to 8x20, and then we continue on. So the reason that I like to leave it a little bit larger size all the way down is for that same reason we talked about earlier with being able to balance the system. If you wanted to close off that half of the house for some reason, we still have enough ductwork up here to push all of that air to the 10 runs on this half of the house, and the ductwork is not undersized for that. So running your ductwork full size the whole way usually costs you like almost nothing extra. Like the difference in price between an 8x24 or an 8x20 or an 8x18 is fairly insignificant. So I just like to leave it full size. It makes the installation a little bit simpler, and you're still going to get proper airflow to all of the vents. And let's address the flex duct situation over here. We've got a couple runs where it was unavoidable to run some flex duct through the attic space. So we've got one here in this entry area, and there's going to be another one right down there. So for this, we basically use some 6-inch insulated flex duct, like what you see laying here on the floor. And this has got multiple layers to it. It's got the actual duct on the inside, surrounded by some fiberglass insulation, surrounded by plastic. Everyone's pretty familiar with that stuff. So for installing this, you need a zip tie on either end, as well as duct tape and some screws. And the way you connect it, I'll just describe it briefly, is you slide that inside portion of the flex duct over the 90 or the piece of metal you're connecting it to, and then you duct tape that in place. After you duct tape it, you run a couple of screws through the duct tape and try to pin one of the wires, because there's wires going around in a circle inside of that inner duct. Let me just show you. So when you put your screw in, so you'll put duct tape around the outside of this first, and then try to put a screw in where it kind of grabs a hold of one of these wires and holds it in position. Once you finish that, then you slide the insulation and plastic out over the outside, and then you zip tie that in position over the top of your fitting. So we've got about 3 runs that are going to be going through the attic like that, and then connecting over to the other side. So flex duct is handy. Oh, the other thing that's important is make sure that you keep your flex duct tight. A lot of times the tendency is like, oh, just throw it in there, and it's kind of like weaves around like a snake in the attic, but that's really not what you want. The less tight the flex duct is, the more air resistance there will be, because if it's not pulled tight, it has a lot more like of a crinkly, jagged inside that's going to slow down the airflow. So make sure that the flex duct is fairly tight. It doesn't have to be like really tight, but just don't leave a lot extra laying up in the attic. Like if you have 3 feet of extra flex duct, it's tempting to just be like, oh, we'll just throw it in there and not trim it down, but it's best to trim it down to the proper length. All right, let's talk about duct sealing. A lot of areas and codes are requiring that you seal your ductwork with mastic or something similar, basically like some sealant that you paint on the seams of the ductwork or some kind of tape. And my opinion on duct sealing is that if it's in the thermal envelope, which meaning it's in the building, it's in the conditioned space, like all of this ductwork here is in the conditioned space. If that is the case, then duct sealing is really unnecessary. The only argument that you could make for duct sealing being better inside of a conditioned space is that in theory, if those end portions of the wall right there on the rim joist are not properly sealed, and there's a little bit of air leakage coming out of your ductwork into like the drywall cavities, some of that air could be basically forced out of those rim joists and wasted essentially if those aren't sealed. Now, that maybe is a little bit of an argument, but generally I'm going to say that that's pretty much bogus, especially on a new build like this where you're able to properly seal your rim joist. You're really not going to lose much air, if any at all. The other thing is exhausting or having your house have a slightly positive pressure, or those joist cavities have a slightly positive pressure and a tiny bit of air leakage going to the outside is way better than having air coming in from the outside. So it's kind of an interesting thing to think through. The other thing that you could do is to cut a couple of like relief vents into your drywall cavities. So let's say we were concerned about the drywall being pressurized in this soffit, okay? If that were the case, we could add a little return air grill or whatever, just like a little grill on the ceiling right here that would relieve any pressure inside of this entire system of ductwork. So if the air leakage from the ductwork is a concern, it will have a path to leak back into the conditioned space. Again, with the conditioned space thing, any air leakage generally is going to go into the thermal envelope, so you really don't need to seal the ductwork. So I would not recommend sealing the ductwork unless it's either A, required by code in your area for some reason, or B, if it is in an unconditioned space. So if your ductwork runs through the crawl space and the crawl space is not conditioned, then it is absolutely essential that it's insulated and perfectly sealed. The same goes for if it's in the attic. It needs to be absolutely very well insulated and very well sealed. But in the conditioned space, duct sealing is mostly a hoax. In fact, I talked to a guy that is, I don't know, he's big in the development of one of the international building code things or something, and he was talking about how this duct sealing thing has gone totally out of control and it makes no sense, especially on an existing system. So ductwork is chronically undersized in most builds and most properties. So in an undersized ductwork scenario, let's say you have a furnace that's a 80,000 BTU furnace with a 3-ton air conditioner. The ductwork is already undersized. The system works, but it doesn't have much flexibility with its ability to push the right number of CFM through the ductwork. So now you have these people that are renovating or whatever, and the building code officials like, hey, you need to duct seal this. You need to, every nook and cranny of your ductwork needs to be perfectly sealed. And the ductwork is running in a conditioned basement, so it's an exposed ductwork in the basement in a heated space. They go through and they seal all of those little cracks in the ductwork, and all of a sudden you lost 10-15% of your air delivery to the system because it was basically using those leaks in the ductwork to heat and condition the space. So now you took a bad situation with oversized equipment and you made it worse by sealing all of the little cracks on the ductwork and reducing the amount of airflow that is available. So take a common sense approach with duct sealing, do it if necessary, and you know, just go from there. You can only do what you can do. Sometimes you have to just do what the inspector requests of you. If you guys have any comments or thoughts about all this, obviously there's a huge variety of opinion on what's the best thing to do and how you should go about it and all that. So leave those comments down below. If you found this to be helpful on your project, if you're kind of in the process of working on your ductwork system, do me a favor, hit that thumbs up button, subscribe for more videos like this one, and we'll talk to you guys in the next one, which I'll put a couple of related videos here on the screen for you guys to choose from. I'll also try to link to the essential ductworking tools in the description.